I'm back, and so what I have written up here is the two equations now that we have covered. So this is our basic working definition of what speed or velocity is. It's the distance that something travels r divided by the amount of time it takes it to do it in. Then we've got this equation over here, which is our basic working definition of what acceleration is. So acceleration changes your speed over time. And then if you don't like the triangle thing, we can open it up and say that it's your final velocity minus your initial velocity divided by time. So this is equivalent to this one up here. Now these two equations though are kind of like your definitions of what speed and acceleration are, but they're not useful really for figuring out your instantaneous speeds and positions. So what do I mean by that? Let's pretend that you got a series of hills and then you're in a car and you're going to go from here over to here. Well, you could measure on a map the distance from there to there. So that would be the letter R. That's the total distance that you travel. And then with a stopwatch, you could measure the time it takes you to travel from here to here. And so then you would take the distance you traveled divided by time, and that would be your average speed from here to here. But it's not your instantaneous speed, because as you're climbing this hill here, you slow down. And then when you get to the top of the hill and you start to go back down it, you start to speed up. So your instantaneous speed, the speed at these various points along here, could be changing. And we would like to have an equation that would allow us to predict what is your speed at these different points. And so here is an equation that's going to allow us to do this. So this equation is going to say that your final speed, okay, the speed that you have at any point along this, is going to be equal to your initial speed. So how fast were you going before you clicked your stopwatch? And then plus a t, where a is going to be your acceleration, and then t is the time at that particular point. So this is the amount of time that goes by, and then this formula will tell you how fast are you going at this point. So if you know the time it took you to get to there, then this formula will allow you to figure out what is your velocity at that point. So that's going to be called the how fast equation, because it tells you how fast that you're going. And notice it depends on three things. What was your initial speed before you clicked the stopwatch? What was your acceleration? And then how much time has elapsed? So in the previous part, what we did was we looked at the moving man from a conceptual standpoint. There wasn't any math involved. Now there is. So let's go to the simulation here, and we're going to enter some data. So given the following values, an initial position of 0, it's always going to be 0. An initial velocity of 3 meters per second, and an initial acceleration of 2, and then you're going to start the simulation. So let's go back to the simulation here. You're going to put those values in for your position, your velocity, and your acceleration. Then when you press the go button down here, it starts the stopwatch. Okay? So you want to time how long is it going to take for him to hit the wall. So calculate how fast is he going to be going when he hits the wall. Well, we need to know the time it's going to take for him to hit the wall. So once you start the simulation, look at the stopwatch, and then observe what is the readout on the stopwatch whenever he hits the wall. And remember that you can pause the simulation. So once you start it, once he hits the wall over here, you can stop it, and then you can read what does the stopwatch up here say. Okay, then you're going to calculate the final velocity using this equation up here. So once you've got your information here, you can then use this formula to calculate the final velocity. And now the problem though is that this simulation does not have a speedometer. So it doesn't actually tell you how fast he's going. It would have been very nice if that had been on there. But later in the lab, you're going to figure out a way of doing this. Okay, so just hold on. So just get this final velocity down here, and then later we'll verify that that was the correct answer. All right, so that takes care of part 2, and when I come back, we will talk about part 3.